everyone. We're Mimicker, here to introduce all kinds of knowledge, even the stuff we didn't know about. So for today's deep dive, we're looking at something that, honestly, caught a lot of people by surprise just a couple of months back. We're talking about Typhoon Fung-wong.
Right, a late-season storm that just showed up when everyone thought typhoon season was long over.
Exactly. It made landfall on the Hengchun Peninsula, that's in Hengchun, Taiwan, on the evening of November 12th, 2025. The exact time was 7:40 p.m.
But the truly wild part, the thing that made everyone's jaw drop, wasn't that it arrived late. It was how fast it died.
It was instantaneous, 20 minutes. 20 minutes after hitting land, Fung-wong was just gone, downgraded to a tropical depression.
Just poof,
Yeah.
vanished.
So that leaves us with two big questions we really want to unpack here. First, how on earth did a typhoon even get going in late autumn? And second, why did it get extinguished so quickly?
To get that, you really have to start with the basics. We need to look at the recipe for what some meteorologists call typhoon soup.
Okay, I like that. So what are the ingredients?
Well, a tropical cyclone is basically a massive heat engine. And to build one, you need a very strict set of 4 conditions to be met. It's not easy.
Let's start with ingredient number 1, the fuel, I assume.
That's it. Warm ocean water. It is the single most important energy source. And it can't just be lukewarm.
There's a minimum temperature, isn't there?
There is. The sea surface temperature has to be at least 26 to 27 degrees Celsius. That's roughly 79 degrees Fahrenheit.
And why is that specific number so important? What's the magic?
It's all about evaporation. At that temperature, you get huge amounts of water evaporating into the air as water vapor. That vapor rises, it gets cooler higher up, and then it condenses back into water droplets to form clouds.
Right.
And that process, condensation, releases a staggering amount of energy called latent heat. That is the true fuel that powers the storm's core. If the water's too cool, say 24 degrees, the pot it won't boil. You don't get enough energy release.
Okay, so you got the hot water, the fuel. What's ingredient number 2? It has to be in the right place, I'm guessing.
Precisely. The right location. You need to be over the ocean somewhere between 5 and 20 degrees north latitude. It's sort of a Goldilocks zone.
And that's because of the Coriolis force.
Exactly. That's the spin from the Earth's rotation.
Yeah.
If you're too close to the equator, below 5 degrees, that force is just too weak. A storm can't start spinning.
And if you're too far north...
The spin is strong, but the water is usually way too cold.
Mm-hmm.
So you need that perfect balance of heat and rotation.
Makes sense. So heat, check. Location, check. The third ingredient, the sources called it a whispering night. What does that mean?
I love that description. Meteorologically, it means low vertical wind shear.
Break that down for us. Wind shear.
It's just the change in wind speed or direction at different altitudes. Imagine you have this column of warm, rising air, the chimney of your storm.
Okay.
If you have strong winds blowing one way at the surface and another way high up in the atmosphere, that's high wind shear.
Yeah.
It tears that chimney apart.
So it disrupts the whole structure.
It completely rips the top off the storm clouds. The energy can't stack up vertically. The storm can't get organized. You need calm conditions, a whispering night, to let that structure build straight up.
And the last piece of the puzzle?
You just need an atmosphere that's already unstable and full of moisture. You need plenty of ingredients in the pot, ready to go to keep the thunderstorms firing continuously.
And all 4 of those things, they're easy to find from June to October. That's peak season. But by November, the whole environment should be hostile to typhoons.
It should be. The sea cools down and the northeast monsoon kicks in, which massively increases wind shear. The fire is supposed to be turned off.
Which brings us back to Fung-wong. How did this anti-seasonal bully, as one report called it, even happen? It needed a special script.
A very special script. And as a combination of things. Factor 1 was, global warming. The furnace was left on.
Right. The data we collect shows that the period from 2015 to 2025 was one of the hottest on record for the oceans.
And what that means in practice is that the oceans are storing so much heat that the normal autumn cool down is.
Yeah.
It's just much slower.
So even in November, the water around the Philippines and Taiwan was still well above that critical 26-degree mark. The pot was still hot.
The pot was still hot. And that was made worse by factor 2, a developing weak La Niña.
Okay, so we hear a lot about El Niño. How does La Niña help a typhoon form so late in the season?
They're opposites. El Niño pushes the warmest water out toward the central Pacific. But La Niña does the reverse. It strengthens the trade winds, piling up the warmest water in the western Pacific.
It concentrates the fuel right where storms like to form.
It creates this superheated warm pool, The atmospheric agency in the Philippines actually issued a warning.
Yeah.
They said because of La Niña, the Western Pacific would be much more likely to see typhoons from October all the way to December.
So we got the heat and we have it concentrated, but the storm still needs a safe path. That brings us to the third factor, this really weird atmospheric setup.
This was Fung-wong's golden ticket. The data showed that the high-pressure system that usually sits south of Japan was much stronger than normal and also positioned further north.
Now, what does a big high-pressure system sitting there do?
Two crucial things. First, it acted like a shield. It blocked the northeast monsoon from coming down and creating that high wind shear we talked about.
It created that whispering night.
It did. And second, it created a perfect path. The winds flow around the edge of a high-pressure system, so it basically created a highway that steered Fung-wong directly from the Philippine Sea straight towards Taiwan.
Wow, so it's this crazy convergence. You've got the long-term trend, global warming, you have the regional pattern, La Niña, and then this short-term atmospheric glitch with the high-pressure system.
It's like trying to boil water outside in the winter. You can do it, but only if you keep the fire burning extra hot and build a wall to block the wind. That was the special script for Fung-wong.
Okay, so all that buildup for what turned out to be an incredibly short finale. It hits land, and in less than 30 minutes, it's just gone. A normal storm can last for hours over land. Why did this one die so fast?
It was a brutal 1-2 punch. The first blow was the energy cutoff. It was instant.
Right, like you said, these things are heat engines that run on warm, moist ocean vapor. Land doesn't offer that.
Not at all.
Okay.
The second it moved over the Hengchun Peninsula, the fuel line was just severed. The air feeding into the storm was suddenly cooler and drier. It created a moisture deficit.
So the engine starves.
The engine starves, the condensation stops, the latent heat release stops, and the whole structure just starts to collapse from the inside out.
And while that was happening, the second punch landed. The terrain.
The terrain finished the job. Taiwan's central mountain range is no joke.
Yeah.
Even at the southern end, it acts like a giant blender. The friction from the mountains just shredded the storm surface winds.
And Fung-wong was a pretty small and not very organized storm to begin with, right? It didn't have a strong, well-defined eye.
It had zero resilience. A big, powerful Category 4 storm can handle that friction for a while. A small, scrappy storm like Fung-wong just disintegrates on contact. The structure was torn apart before the lack of moisture could even fully suffocate it.
So the wind threat was over in minutes. But that wasn't the end of the story, was it? The rain, especially up north, was a whole other issue.
And that's the co-movement effect. It's classic for these late-season storms. Fung-wong's center was gone, but all that moisture in its leftover clouds had to go somewhere.
And the northeast monsoon was already there waiting for it.
Like a conveyor belt. The monsoon scooped up all that remnant moisture and just slammed it into the mountains of northern Taiwan, leading to hours of heavy, prolonged rain. It really proves that the tail of the storm can be just as dangerous.
It's an unconventional story, but looking at the historical records, it's not totally unprecedented, is it?
No, and that context is so important. The closest parallel we have is probably Typhoon Gilda back in 1967. That was the only other typhoon on record to directly hit Taiwan in November.
And then there was Niña-like, which was even later.
Niña-like's the record holder, early December 2004. And again, it wasn't a huge windstorm, but it teamed up with the monsoon and dumped over 1,000 millimeters of rain on Hengchun. Catastrophic flooding.
And the common thread in all of them, Gilda, Niña-like, Fung-wong, is abnormally high sea temperatures and some kind of weird atmospheric pattern that suppressed the wind shear.
Every single time. That's the only way it can happen.
Which really brings us to the big takeaway here looking forward. Fung-wong feels like a sign of the new normal.
I think that's undeniable. The traditional lines on the calendar are blurring. The oceans are staying warmer for longer, which means the off-season for typhoons is getting shorter and shorter.
You can't just circle June to October on the calendar anymore.
No. And we have to completely rethink what the threat looks like in November or December. The emphasis is shifting from wind to rain.
Because warmer air holds more moisture.
About 7% more for every degree Celsius of warming. So even a structurally weak storm like Fung-wong can carry a devastating amount of rainfall. Our disaster prep has to evolve. We need to focus on flash floods and landslides, especially when these storms interact with the monsoon.
So the story of Fung-wong, this little storm that lived and died in a flash, is really a warning. It's a high-speed preview of how climate change is messing with the seasons we thought we knew.
The preparation can't be seasonal anymore. It has to be a year-round state of readiness, focused on these complex rainfall events.
So if there's one Single idea to take away from this, it's that relying on what's normal or what's happened in the past, that's just not a reliable guide anymore.
Not at all. And I think the final takeaway from all the data we've looked at really says it best. In a changing climate, there is no such thing as a permanent off-season. Only by being prepared can we handle the storms that arrive out of time.
Thanks for tuning into this episode. If you enjoyed our content, don't forget to like, subscribe, share, and turn on the notification bell. See you guys.